This is a World War II bomber generator. This is a 200 amp 24 volt generator made by Westinghouse. It's a model P-1. I think they were made by a number of different manufacturers under license. And I'm going to show you how to test this using our custom-made test stand. And one thing I wanted to point out while this is off, these are the two output studs. The large studs are the output studs of the generator, and these two smaller connections are the field coil. So one of the things you need to know before you do anything is which terminals are positive and which ones are negative for the DC output. And the easy way to tell that is to focus on the two small connections. And you'll notice there's a strap, a copper strap here that connects the large stud to the small stud. And that's the negative side of both the field coil and the output of the generator. So whenever you're connecting this to the test stand, look for that jumpered connection there, and both of those are negative. So your negative battery cable goes on here, your positive battery cable goes here, and the positive connection for the field coil goes on this small terminal here. On our test stand, we have a splined coupling here and a mount for the generator. It stands vertical, and it's just a matter of, there's two welded studs there, so it's just a matter of slipping the generator into the spline coupling, lining up the two studs with two of the mounting holes, and putting a nut on there just to hold it in place while we're doing the tests on the test stand. So we'll take the generator and mount it in there. Okay, so the generator's sitting down on its base, and we'll put the nuts on the pull-down studs. After tying the generator down to the base, we're going to hook up the cables. Negative on the left, positive on the right, and our field connection goes on this terminal here. For testing the generator on the test stand, we're going to run the engine. There's a belt drive that spins the generator, and notice that we do not have the voltage regulator hooked up to it. When we're testing the generator for troubleshooting purposes, or we may have a generator that was in stock and we want to test it, don't use the voltage regulator because we're not quite sure what the unit is going to do. So we're going to connect the field wire up to a DC variable power supply and start off at 0 volts, and we're going to apply that voltage to the field coil, and we're going to bring it up very slowly to see what the reaction of the generator is. So I have the positive wire on the field control coil, and the negative wire is hooked to ground, which is the negative output terminal of the generator. So what we're going to do now is start it up. We're going to come down here and slowly bring the voltage up on this. It might only take 2 or 3 volts to get a full 24 volt output on the generator. And we'll look at the voltmeter on the test stand to see what the effect of our field coil input is to the output of the generator. And then lastly, we're going to take the engine throttle and move the throttle up and down so you can see the variable voltages that you get out of the generator. If we have a fixed voltage going into the field coil, just by merely changing the throttle RPMs, we can have a real big swing on voltage. And in a later video, we'll be talking about the voltage regulator, and that will show you the importance of the voltage regulator in keeping a stable 24 volt output on the generator. So here we go. We'll start it up. So we put 3.12 volts into the field coil to get a 24 volt output on the generator. However, when we change the throttle settings, by reducing the throttle, the generator went all the way down to 15 volts. And when we increased the throttle, it went all the way up to 30 volts. That's a 15 volt swing just by changing the throttle settings. Shows you how valuable the voltage regulator is in keeping the generator at a stable output.